sorry, there's a little dinging which may happen now and again because my computer registers my text, so I apologize for that. But hey everyone, it's nice to be with you. Before we get started, I would love to get a sense, if I could, if you wouldn't mind, of where everyone is from, what grades you're in, and that kind of thing. And if you don't mind, you can just throw it in the chat.
I'm from Michigan, and yeah, I go to South Point.
You go to South Point? Awesome.
Yeah.
And what grade are you in?
Third. I'm in third grade.
Third grade. What? That's awesome that you're here. Nice to see you.
Say thank you.
Thank you.
I'm also in third grade.
You're also in third grade. I think I recognize that voice. Good to see you, Vihan.
I'm in sixth grade. I go to Clegg Middle School
Clegg
in Ann
Middle.
Arbor.
Good to see you, Autumn.
Hi.
Anyone else want to introduce themselves? You're from Kansas. Oh, another Clegg student. Okay, in seventh grade. Oh, sorry. Go ahead.
Well, my name is Ajane and I'm from South Point also. And I'm in sixth grade.
Sixth grade. Awesome. Nice to see you. So we've got some seventh graders, some sixth graders, some third graders. And do you have a friend with you, Ajane? No, maybe. All right. Well, and I see another camera that just came on. Do you want to introduce yourself?
So,
Hi, I'm Corinne. I'm from South Point.
And what grade are you in, Corinne?
Sixth grade.
Nice to see you.
wave.
All right. So, so I guess we can get started. How many of you all have heard about climate change? No? Yes?
I
You
have.
You have. Has anyone not heard about climate change?
No.
No? Okay, good. So this will be an introduction for you. Has anyone here, I want to clear up something before we start, because this is a very common misunderstanding that a lot of people have, a lot of grown-ups, I should say, have. Not even kids, but who has heard of the hole in the ozone layer? Has anyone heard about that?
I have.
You
I
have. You have. How about other people? Have other people heard about the hole?
Not at all.
Not at all. Okay. Yeah. I just want to clear up, because I think some people have heard about the hole in the ozone layer and think that that is causing climate change. And those two things are totally unrelated. So before I talk about climate change, I actually want to talk a tiny bit about the hole in the ozone layer, because I think it's a good history lesson for us. So back in the 80s, we realized that high up in the atmosphere, not the atmosphere that's closest to us, but higher up than that, there was a hole that was developing in the ozone layer. And what the ozone layer was doing for us is that it was taking harmful radiation from the sun, like sun rays that would not be good for us at all. And it was it was that part of the atmosphere that would block those. It was developing a hole so that we were going to be exposed to a ton of harmful radiation. And the world community immediately reacted. And what is interesting about it is they came together and said, oh my gosh, this is a really big thing and it's bad and we have to fix it immediately. And the whole world got together and they did something about it right away. And for those of you that know a little bit about the US government, you know that senators have to ratify international environmental treaties, right? So right now we have a bunch of senators from different parties in our government. How many senators do you think signed on to ratify this treaty back in the 80s to stop the hole in the ozone layer from happening?
All of them?
Yeah, all of them.
All of them. That's right. Can you imagine all senators now like saying, I'm going to do something, and all of them working together? It's kind of hard to imagine. But there has been times in the past when we've all come together and worked together to protect our planet and protect all of us. So I just wanted to say that. All right, I'm going to share a little bit of a presentation. Tell me if you start to get a little wiggly or squiggly and you want me to slow down, or you want me to explain something, or you want me to just stop and take a break, and I'm happy to do that. Does that sound good? Oh my gosh, I do not know how to turn off these texts that are coming in rapid fire. So sorry, you guys, you might have to deal with a little bit of dinging now and again. Gosh. All right, here, let me share my screen. All right. So can everyone see my presentation?
Yes.
Yeah, I got thumbs up. All right, thanks guys. All right, so here we are, climate change, science scenarios and solutions. And my name's Smita. I teach at Washtenaw Community College, and I teach environmental science. And we have a bunch of classes at WCC that talk about environmental science. We have a bunch that talk about geology and climate change in a bunch of different ways. We have a philosophy course that talks about climate change, because it's super, super important. And we'll talk about why in a second. But before I talk about climate change, I want to talk about something called the greenhouse effect. Has anyone heard of the greenhouse effect?
Yeah.
Yeah, a
Yeah.
little bit. You have? Okay.
There's
Anybody?
in a book I read about it.
Yeah, you read about it. Okay. And I have a sideways thumb, which means I've sort of heard about it maybe, but I don't really remember if I heard about it, which is totally fine. So oh, hang on. I think it's going to be hard for me to monitor the chat at this time. All right, that's all right. We'll just do it this way. So I'm going to ask you guys, you're welcome to use the chat. I'm not sure if I'll see everything that you say when you use the chat. So you're also welcome to just shout out and let me know when you want to say something. So before I talk about climate change, I want to talk about the greenhouse effect, because the greenhouse effect is something that keeps us alive on this planet. Without it, we would be way colder than we are now. So it's actually a really helpful thing. And I like to start off talking about it because it helps people understand like where climate change is coming from, or what like the mechanism is for climate change. So how the greenhouse effect works is the sun puts out a bunch of energy, and that energy is part of a spectrum of light called ultraviolet and visible light. And that ultraviolet and visible light, it passes through our atmosphere. A lot of ultraviolet light gets stopped in the stratosphere from the ozone layer. Some of it passes through, but a lot of visible light can pass through our atmosphere. Some of that, about half of it, gets reflected right back into space. If you think about all of the ice on our planet, or different reflective surfaces, or even clouds and aerosol in our air, they just reflect that light right out back into space, and it doesn't really hit the earth. Some of it though does hit the earth, and it gets absorbed by darker surfaces in the earth. And then the earth takes that radiation and then it puts it back out, but it doesn't put it back out as visible light or ultraviolet light. it puts it back out as heat, as infrared radiation. And remember, our atmosphere lets in ultraviolet light, but it doesn't let back out heat as easily. It gets trapped by these greenhouse gases in our atmosphere. And that's what the greenhouse effect is if you've ever, have you ever opened a car door on a summer day and realized that the inside of that car is super, super hot? It's kind of the same thing. And we're not the only planet in the solar system that has a greenhouse effect. We actually figured out a lot about climate change and the greenhouse effect by looking at a neighboring planet, Venus, which is super, super, super hot, mostly because most of its atmosphere is greenhouse gases. So that's a little bit about how the greenhouse effect works. And it'll become more clear why I'm explaining this, but it's heat that gets radiated out from the earth after the earth has absorbed radiation from the sun. And so what are those greenhouse gases? I wanted to spend a little bit of time talking about them. Carbon dioxide is probably like one that a lot of people have heard of. And that comes from a lot of different places, but it comes a lot from burning fossil fuels. So what are fossil fuels? Gas, coal, oil. It's the stuff that powers us right now, and powers most of the world right now. Carbon dioxide is really important, probably for a couple of reasons. One, because it is the greenhouse gas that is the largest by volume, but also because the carbon dioxide that you and I put out today is going to stay in the atmosphere for a long, 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 long time. So the carbon dioxide that I put out today by turning on my lights or heating my house, that is going to be in the atmosphere probably for another 1,000 years. So once it's up in the atmosphere, it doesn't go away. Methane is another greenhouse gas. Has anyone ever heard of cow belches or farts? Kids tend to know this, that cows belch. Yeah.
Yeah, we covered that in 5th grade.
Yeah, you did. Okay. So cows belch and fart methane. And methane is a greenhouse gas. There isn't as much of it in the atmosphere as there is of carbon dioxide, but it's more powerful. But the good thing about methane is it doesn't stick around for quite as long. Nitrous oxide comes from a lot of places, but most of it comes from fertilizer. So if you think about the fertilizer that you put down in your garden or on your lawn, or that other people put down on their lawns, a lot of that is nitrogen, and a lot of that nitrogen on the ground actually ends up in the air. And then you have these like little 3 categories right here, which are all fluorine gases. Fluorine gases, there aren't that many of them, but the ones that there are super powerful. So 1 molecule of fluorine gas can warm the atmosphere like thousands of times more than 1 molecule of carbon dioxide. And I have some good news about fluorine gases, which is that pretty much we have decided, the world community has come together and decided that we are going to phase out the warming fluorine gases in our atmosphere. So we're going to phase out using them, which is a big deal, because that in and of itself will save us 0.5 degrees Celsius of warming. So and it's not hard to do, and actually it will create jobs and be good for our economy. So that's some good news about that. I want to show you something called the Keeling curve, which is probably one of the most famous curves in climate science and environmental science. Can someone look at this graph, someone other than a Kalantri, and tell me what might be going on here? What is this graph showing us? What is the long-term trend in this graph? You have
It's getting worse. There's more.
That's right, Josh. Yeah, it's getting, so the concentration of carbon dioxide in the atmosphere is going up, right? And you can see that we're at about 415 parts per million. So for most of human history, we used to be between almost all of human history, we used to be between 180 and 280 parts per million. And now we're all the way up at 415 parts per million. What does that mean for how much we're going to warm the planet? Scientists aren't really sure yet, but we think that it could mean that we could warm as much as 3 degrees Celsius, which is about 6 degrees Fahrenheit. So it's never been this high throughout human history. So it's definitely a cause for concern. Maybe I can also ask you guys, someone that's not a Kalantri, what is that jagged? What you see that the graph is jagged. There are these ups and downs. It's not a smooth line. What do you think is going on there? Does anyone have any guesses? Any ideas? Okay, someone that is a Kalantri.
I think it's from like seasonal ups and downs.
Okay, what would cause seasonal ups and downs in carbon dioxide?
I have no idea.
Yeah, Vihan, do you have an idea?
I think it's like from the year, like how much like carbon dioxide goes into the air.
From the year?
Yeah.
Josh, what do you think?
It could be how we make more factories, and as we progress through like technology, we make factories so we can make food and all that. And the more there is, the more carbon dioxide there's going to be.
Yep, that's absolutely true. And that's absolutely,
Is it pollution?
is it pollution? That's a good, yeah. And actually we would talk about climate, carbon dioxide. Now we think of it as a pollutant. It's not a pollutant in the same way as like smog, which is going to damage your lungs, but it's definitely going to harm society. So we actually think about carbon dioxide as a pollutant now. So you're, and Josh, you're right. This is a long-term, and Vihan, you're right too, that this is a long-term trend that every year you see more and more factories and more carbon emissions go up. But why, but you see that it goes up year to year, like up and down, up and down, up and down in between. The reason for that actually is trees, believe it or not. Trees are amazing, amazing, amazing living organisms. So every year in the winter, trees aren't taking in trees. Every year, what happens to trees in the winter?
They lose their leaves.
They lose their leaves, right? And plants aren't growing as much. So plants aren't growing as much, and trees lose their leaves. And so carbon dioxide isn't taken out of the air. In the summers, when everything is in bloom and things are growing full steam, plants growing, trees growing, that stuff actually sucks carbon dioxide out of the atmosphere. So what you see on this jagged up and down is actually the seasons, winter and summer. In the summer, carbon dioxide concentrations go down a bit. In the winter, carbon dioxide concentrations go up a bit. So it's kind of amazing to think, but trees are so important in the fight against climate change because they are the only thing that we know right now that it does a really good job of pulling greenhouse gases out of the atmosphere. And that's why one reason why protecting forests is such an important part of fighting climate change. Protecting forests and wild spaces just generally. And not just protecting forests, I should say, but also planting trees all over the place in urban areas, in neighborhoods, and in different habitats. So I'm going to show you this quick video. I think it should play. Hang on a second. Oh, okay. Hang on, I have to enable content. There we go. All right, can you see it now? Okay, I'm gonna play this quick video, and this is gonna show warming from 1880 to 2020. And this will show you how the globe has warmed since then. Keep your eye, especially up top in the northern latitudes near the North Pole, but all over generally too. So we're at 1958, 1960s, 1970s, the 1980s and 90s are where you really start to see a change. And this is where we are now. So you can see that we're definitely, we've definitely warmed the planet, especially recently. I think from the 1980s onward, people say like, oh, if you were born after 1988, you've never lived in a climate that was normal or natural. You've always lived in a climate that was been manipulated by people. So does anyone have any reaction to that video? Sometimes people are like, what? That's crazy how fast it warmed. No? All right, that's okay if you don't, we'll move on. So here are some different impacts of warming. So we used to think that if we stayed under 2 degrees Celsius of warming, that would be fine. And no one would get badly hurt and there wouldn't be a lot of damage. And now we realize actually the best science tells us that we have to stay under 1.5 degrees Celsius. And the difference between 1.5 to 2 degrees Celsius can be pretty big. It doesn't sound like half a degree Celsius, right? Like that's 1 degree Fahrenheit. It doesn't sound like much, but actually it is kind of a big deal. And one of the reasons for that is because there are tipping points in the climate, which we'll talk about in a second. But one thing that I wanted to point out is coral reefs. So when we go, and I say when, because most people think that we will go from 1.5 to 2 degrees Celsius, we'll go from losing most of our coral reefs to all of our coral reefs. And that's a really big deal for a couple of reasons. One reason is because just like rainforests are to the earth, coral reefs are to the ocean. They're the most biodiverse place on the planet in the ocean. And they're the reason that we have a lot of fish in the ocean. So if we see coral reefs go away, we probably will also see a lot of decline in fish populations, which are also already in trouble. And that's going to really hurt people that depend on fish for food. But one thing that I wanted to, but there are other impacts as well. There's populations exposed to severe heat. You see that just going half a degree Celsius, 1.5 to 2 degrees Celsius, there are people that live, millions and tens of millions of people that live near the equator of our planet. Those people won't be able to live there anymore. And you'll probably see this in your lifetime because the combination of heat and humidity will be so bad that you actually can't step outside for more than you actually wouldn't be able to be outside for more than a few hours because the heat would be deadly. It would be that hot. So this is kind of a really big emergency for people in that part of the world who don't have access to air conditioning, who don't have access to cooling stations or anything like that. They will have no choice but to move. Josh, did you want to say something? Sorry, I see that your mic is on.
Oh yeah, sorry. So
You're fine.
I noticed that it's like every degree Fahrenheit is almost like 1.5 or double. In a lot of cases, like loss of habitat, vertebrae, decline in fisheries,
Yeah.
population exposed to floods. Like a lot of them are double or close to doubling.
Yeah, absolutely. It makes it's surprises a lot of people, I think, because it's such a small change when you hear it in temperature, 1.5 to 2 degrees Celsius, right? Like it doesn't sound like a lot, but the earth isn't linear. Like it's not like you have it's not like you warm by a few degrees and it's just a few more degrees of impact. The earth actually has tipping points built into it. So like if you pass certain tipping points, all of a sudden you're falling down this cliff that you didn't anticipate, that you couldn't have seen coming forward. It's like, you guys, when I don't know if you remember when COVID first happened, right? In the very beginning of COVID, it was like, oh, it's just a few cases here, it's just a few cases there. And then all of a sudden, bam, school gets shut down, right? Because all of a sudden you reach this point where you're like, oh, it's really, really, really big. And by the time you realize it's really big, it's almost too big to stop. So that's something called exponential growth, where something can start out really small and really, really slow, but it can get really, really big, really, really fast. So I think that's a really good observation, Josh. Does anyone else have any observations looking at this? We'll talk more about impacts and stuff, but I wanted to get into like why, what some of those tipping points are, because there are positive feedback loops that are built into how climate change will happen. All right, let me talk about one of those positive feedback loops. So you remember I said that when we looked at that map of warming, you remember I said like, oh, keep your eye on the northern latitudes, on the Arctic. And the Arctic is actually warming twice as fast as the rest of the planet, which is kind of, let me go back here, which is kind of crazy. So if we go from, one of the things that will happen when we go from 1.5 to 2 degrees Celsius is that we'll have 10 times as many ice-free summers in the Arctic, which may not sound like a big deal, right? But it actually is, because the ice in the Arctic and ice on our planet just generally actually acts like an air conditioner for the planet. And if we lose our ice on the planet, we lose our air conditioning and the planet starts to get hotter faster. So let me tell you what I mean by that a little bit. So here's a picture of one of the positive feedback loops that happens to the climate as we get warmer. As we get warmer, sea ice starts to melt. So you remember, if ice gets reflected back out into space, we don't see a lot of warming. But if you have a lot of darker surfaces, those darker surfaces, they absorb radiation and then they put heat back out into the environment. So if we have temperatures go up and we have sea ice melt, we're having less radiation reflected back out into space, and we're actually absorbing more radiation and heating up, which then makes more ice melt, which then makes temperatures go up even more and then melts more ice. And then you have this positive feedback cycle that happens as we cross 1.5 degrees Celsius. So that's what I mean about climate change doesn't happen in linear patterns. It happens kind of abruptly once you pass these tipping points. So 1.5 degrees is where we think we'll lose a lot of Arctic ice, and that will lead just by itself, all by itself, probably to another 0.5 degree of warming, just because of that positive feedback loop. Another example of a positive feedback loop is permafrost. Has anyone ever heard of permafrost, or does anyone have a guess about what permafrost is? Can sort of almost guess from the name. No guesses?
I'm not sure. I mean, I think it has to do with like ice underneath land. I'm not sure.
Yeah, absolutely. Great, Josh. That's absolutely true. So permafrost is land that is always frozen. It never is not frozen. And it's up mostly in the Arctic regions and the polar regions of the Earth. And permafrost carries inside of it a lot of methane. So when we warm the planet, what we're doing is we're thawing out that permafrost, and that permafrost then puts a lot of methane into the atmosphere, And remember, methane is a what kind of gas? It's a greenhouse gas, right? So that methane warms the planet. And then that again melts more permafrost. And then that leads to more permafrost melting and putting more methane out into the atmosphere. And that leads to more melting of permafrost and even more methane. So that's an example of another positive feedback cycle that can happen when we cross over into these kind of climate, I would say, I don't want to make this sound too scary, but like danger zones, like climate zones that are not safe. We risk activating some of these positive feedback cycles. Another example of this would be forests. Remember I said that trees are really good at sucking carbon dioxide out of the atmosphere? Trees, so we have like 3 big lungs of our planet. The first big lung is the Amazon. And when I say Amazon, I mean the Amazon forest in Brazil. I don't mean Amazon, the company, but the Amazon in South America. And then the second big lung, or the biggest sort of tract of really important forest, is in the Congo Basin in Africa. And then the third is in Indonesia and kind of the island of archipelago island of Indonesia and Malaysia and the forest there. We have now started to see that with increased warming, parts of the Amazon in the southeast, they're not actually taking in carbon anymore. They're actually putting out carbon. And as forests get warmer and warmer, they become more prone to forest fires, and they become more prone to disease and transition into different habitats. And so we actually think, and we pretty much know, that as we get hotter and hotter, what we risk is that forests will stop taking out carbon dioxide and actually start putting back out, taking carbon dioxide out of the atmosphere. Forests will actually start putting carbon dioxide back into the atmosphere. So instead of being a carbon sink and taking carbon out, it's actually going to put more greenhouse gases back into the atmosphere. So that's another example of a positive feedback loop. So there are a number of these different positive feedback loops. So when you hear people say like, oh, we need to stay below 1.5 degrees Celsius, or we need to stay below 2 degrees Celsius, you might think like, well, what's the big deal? What's another, what difference does another degree make? Well, that's the difference that it makes, is that we don't want to set up these positive feedback cycles that then lead to like changes that are so fast that we can't control them. All right, so let me talk a little bit about climate justice, because I think this is really, really, really important for people to know. This is a graph. So this is kind of a confusing dinosaur shaped graph, but I don't know if anyone wants to take a stab at describing what it's showing us. Does anyone? Kalantris can join it.
No, stop.
It's small. It's going up and it's getting to be more.
Exactly. Really good. Really good. So it's getting to be more. And what we see on this graph is that this is on this part of the graph, we have groups of people arranged from the poorest people in the world to the richest people in the world, right? And then we have how much carbon dioxide those people put out. So how much carbon dioxide or how much greenhouse gases do the poorest people of the world put out? A lot or a little? Down
A
here.
little.
A little.
A little.
Exactly, a little, almost nothing, right? How about the richest people in the world? How much do they put out?
A ton.
A ton,
A
exactly.
lot.
Yeah.
Yeah,
most
they
of
put out
it, a lot.
exactly. You see, right, that in 2015, the richest 5 people in the world, or at least the richest 10% of the people in the world, they put out as much as the other 90% of the people in the world. So who would you say is driving climate change?
The richest people.
The richest people in the world are the ones that are driving climate change. Absolutely. Sometimes you'll hear people talk about like, oh, we have too many people in the world and we have to stop people from having babies and all that kind of stuff. And well, those people aren't the ones that are driving climate change. It's the richest people in the world that are driving climate change. Well, let me ask you another question. Where do you think a lot of the United States falls on this graph? What do you get? What is your guess? Do you think we're,
The dino's
The
head.
top.
yeah, in the United States, even though, yeah, Howard, you were going to say something.
No, I wasn't. I'm sorry
Right.
though.
Okay. So I was just going to say, you're absolutely right. So compared to the rest of the world, we are actually closer to the head, way closer to the head than we are to the tail. So in the United States, we put out more carbon dioxide than our fair share. Now, having said that, the richest people in the United States put out more than the poorest people in the United States do. So it's not like everyone in the United States puts out the same amount. But the same concept applies, that the richest people in the world are driving climate change. Let me ask you this. Who do you think is going to suffer the most under climate change?
The poor people,
Why do you say that?
because they don't have access to good resources.
Okay, good. Does anyone else have a guess?
I do.
Yeah, go ahead.
People who are closest to the equator.
People who are closest to the equator. Yeah, that's a really good guess. And and you're both right, actually. The poorest people in the world. Well, let me start with the people closest to the equator. The people closest to the equator. Whoops. I can do this now, I guess. The people closest to the equator are often going to suffer from heat-related illness and death because of extreme heat. They're also going to suffer from malnutrition, because a lot of people in the world, they get like a lot of their nutrition, like vitamin A and zinc and iron, from stuff like wheat and corn. But as the climate gets hotter, our crops are actually becoming less nutritious. So now we have a bunch of people that used to be able to get their nutrients from grains and from crops. They won't be able to get them from that anymore. So we put a lot of people at risk for malnutrition. And there are a lot of mosquito-borne vectors. You guys remember this summer, the mosquitoes were so terrible. You can expect to see a lot of mosquitoes in Michigan, and maybe some diseases that we haven't seen before. But certainly, like the richest people in the world will be able to afford air conditioners. They'll be able to build their houses so that they don't flood. They'll be able to build their houses so they don't get washed away in a storm. They'll be able to afford food, even if it's more expensive. It's the poorest people in the world that are going to suffer the most. And that really is why I don't think about climate change as an environmental issue. I think of it really as a social justice issue, as a poverty issue, as a social justice issue. Here in the United States, we're already seeing it happen. We're seeing that communities in Miami, for example, that are further inland and further a little bit higher up from the ocean, those tend to be poor and minority communities. Those communities are getting pushed out of their homes as other more well-resourced people or sort of richer people are coming into their neighborhood. So we're already seeing people being pushed out of their homes. We might not always call it that, but that's what it is. Alia, did you have a question? I see that your mic is on. Sorry, I'm not able to monitor the chat very well because I have like the whole full screen thing going here, but.
Me?
Yeah, did you or no?
No.
Okay, good. All right, So there are two kinds of climate change. There's two kinds of ways of dealing with climate change. One is adaptation, which means like basically we're adjusting for the climate change that we know is going to happen and is happening right now. So if you're in Michigan, you might want to check on your basements because we know that, water, we're going to have a lot more water in Michigan in the future. So we might have more basements flooding. If you're in California and the Colorado and rely on the Colorado River, you might want to try to figure out what you're going to do to prepare for a future in the next couple decades where there's a lot less water. So there are things that we can do to deal with climate change that are adapting to what climate change is going to throw at us. But there's also mitigation, which is stopping the climate change from happening in the first place and cutting and preventing greenhouse gas emissions. And the biggest study that's ever been done about how to do that is something called Project Drawdown. And let me show you the top 10 solutions that we have to fighting climate change. So I'm just going to give you a second to look at this list, and then I'm going to give you a chance to react. Does anyone have any reaction to this, or does anyone? You can also feel free to throw stuff in the chat if you want. Sometimes this list kind of surprises people. Is there anything on this list that surprises you?
Yeah,
Yeah, what's that?
two things. What are solar farms? Educating girls I get, but I can't even pronounce silvopasture.
Silvopasture, yeah. So that's good. That's a good point. What are solar farms and what's silvopasture? Solar farms are basically like huge fields of solar panels, which is different from rooftop solar, which is where people like individually on their own homes, they'll put solar panels on their homes. And silvopasture is where you have grazing and animals, but you have trees mixed in with the grassland. So you plant trees even in places where animals graze, and you don't cut down all of the trees in a habitat just to be able to graze animals. About 75% of the land that we have actually goes to feeding animals, of the agricultural land that we have. So of the agricultural land that we have, the majority of it doesn't even go to feeding people. It goes first to feeding animals and then to feeding people. So yeah, so that's good questions about those. What else? So Alia, you said that educating girls makes sense to you. Why does it make sense to you?
It makes sense because not a lot of girls are educated.
Yeah. And what does educating a girl do, or family planning, letting women and families figure out how many kids they want? It does a couple things. One is it helps them be better stewards in their communities. So it helps them be empowered to be part of climate change solutions in their communities. But the other thing that it does is it keeps them in school, so they don't start families as early, and they tend to have fewer kids, and the kids that they have are healthier and more successful and are less likely to grow up in poverty. So these are things that we should probably be doing anyway. Like, we don't have to talk about climate change to think about, like, we should be educating girls. That should always be a thing that we do. But unfortunately, in some parts of the world, girls are not as able to get an education as boys are. So what about other things? I think it surprises some people that reduced food waste and a plant-rich diet is on this list as number 3 and 4. That's a lot of people, when they think about climate change and how we're going to solve it, they think like, oh, we're going to stop burning fossil fuels and we're going to have solar and wind. And that's an important part of it. But food is also a really important part of it too. remember that I said that a lot of the land that we have goes to feeding animals and goes to producing meat rather than actually feeding people. If all of us just ate mostly plants, then we'd need a lot less earth to grow food for everyone on the planet. And we would be able to have more trees and we would have more wild habitat. So, and also we would probably have healthier people because a plant-rich diet is healthier for you. And the same thing with reduced food waste. We waste, does anyone have a guess about how much food we waste in the United States? What,
I think it's like 6 million tons, something like
Cause I can drink it
A lot.
or some of it.
yeah. What does that, so percentages, what percentage of food, does anyone have a guess?
75.
It's a good guess. We
95.
right? So that would be, oh my gosh, we'd waste almost all of our food. We waste actually about 40% of our food. And that's higher than the global average. Globally, we waste about 30% of food. And the reasons we waste food is different. In poor countries, food often gets wasted because there isn't any refrigeration to preserve the food and keep it. In rich countries, often the food just gets wasted because we don't like how it looks. And so we like people never put it on the shelves and they chuck it, or people buy it, but then they just let it rot in their fridge. So those are two things that I think really surprise people. If we can limit the amount of land that we need to produce food for everyone on this planet and get it to every hungry person on this planet, will not only make people healthier, but will also be more efficient and a more just planet.
And when you say like mostly plants, so sometimes meat is like, it gives you certain things, but there's other things that can give you those nutrients or protein.
Yeah.
But in the case of someone who like can eat nuts or doesn't eat a lot of breads and stuff, or they're lactose intolerant, and they can't get those certain things, sometimes you need to eat like meat, but it's better if we do mainly plant-based, because that's just prevents climate change a lot.
Yeah, that's a great point, Josh, is like, what do you do for kids that have allergies to nuts or to dairy? Like what would you eat if you were trying to be a vegetarian? My answer, and this is what my students make fun of me all the time because I'm like, beans, eat beans. But beans and lentils and legumes, they can provide enough protein for you so that you wouldn't need to rely on meat if you did have some sensitivities or allergies to food. But again, like some people are allergic to different kinds of legumes, so it all depends. But I would say, like, if you really wanted to look into how to be more plant-based, that would be the place to start, is with black beans or chickpeas or lentils or different things like that. Refried beans to move yourself more to being plant-based. In our house, we're not fully vegan, not by a long shot. We have veggie pizza, homemade veggie pizza every Sunday at our house. But we do try to eat vegan, some days out of the week. So, and we are vegetarian. So I think
That's what we do too,
is that what you do too? Yeah. So
even the pizza part.
Oh, do you really? You have homemade pizza on Sunday?
Yeah.
Oh, that's so awesome. Yeah, so do we. So I guess what I'm saying is, like, everyone has to figure out for themselves what they can do and how they can contribute and what works for their family. I have a lot of students that say, I want to be vegan, but I'm still living with my family and they only cook meat, and so that's what I eat. And I'm like, well, that's what works for you and your family right now. And when you're ready for something else, you'll figure something else out. We're all doing the best we can. So I sometimes have students that say like, oh, I'm not perfect. I use my car sometimes and I eat meat sometimes, and we don't necessarily have to take the weight of the world on our shoulders, but we can, I think there is value in trying to live a life of integrity, right? Where you're living a life that's in line with what you value and what you think is important. So does that make sense?
Yeah.
Yeah, kind of.
It's
Okay.
it's kind of complicated though, because like I'm allergic to like dairy and blackberry, so it's kind of weird because I kind of don't know what I can eat right now.
Yeah, it's hard. It's definitely hard. And I would say, talk with your parents and talk with your doctor about what makes sense for you. And I think it's never going to hurt you to, unless you're allergic to those fruits and vegetables, it's always going to be a good idea to eat more fruits and vegetables. But obviously like every kid is different. So, all right, I'm not sure, I'm just gonna check what time it is. I hope I'm not taking too much of your time. Okay. Does anyone have a time check for me? What time is it, guys? Oh no, it's 2 o'clock. I'm time's up. All right. All right, tell you what, I'm gonna just show you this last slide really fast, okay? Sorry, guys. And we
No
won't.
worries, Smita. We started a little bit late, so we're enjoying our time. Thank you.
Okay. Okay, good. I hope I'm not overstaying my welcome here. Hang on just a second. Gosh, you guys, how do I, oops. Here we go. Sorry, I got it. All right, so what can kids do? There are a couple things, like if you want to try and make a difference as a kid, I think sometimes kids feel like, oh, I'm just a kid, what can I do? Well, the fact of the matter is that kids are the ones that are on the front lines of climate activism and teaching adults and showing adults that what we do now really, really matters. And I think that is in large part because as kids, adults are going to be long gone by the time this gets to be really serious. As kids, you're going to be bearing the worst impacts of climate change. This is your future. And kids are realizing that they can't just trust adults to do the right thing. They need to hold adults accountable. So kids are really, really powerful. I don't know if you all have heard about climate strikes that kids have been leading, but there have been millions of kids all over the world that have been striking for climate justice. And so, raise your voice. But some things you can start doing right now, buy less stuff and buy used stuff, because it takes energy to buy stuff, and the less stuff we buy, or the more stuff we can share with each other and buy used or trade with each other, that's going to be less that has to be produced and less energy that needs to be used. Eat less meat and don't waste food. We talked about that a little bit. If it depends on family to family, but if your family is up for it, you could try eating less meat and try not to waste the food that you have. Now, do I mean that you need to go to your parents and be like, hey, we need to eat less meat, start cooking differently? That's not really going to be super helpful to your parents. But what I am suggesting is maybe that you look up a recipe and you're like, hey, this is something that we could maybe try. Can I help make it? And then maybe your parents would be willing to try it with you. So that's something to think about. Walk and bike when you can. I know this is hard, especially in the winter, but it's good for you if you can. If you live in a neighborhood where you are able to walk or bike, or even if you want to get to a friend's house and they're not super far away, walk or bike when you can. It's good for you, and it's also good for the environment. Try to learn a lot in school. This is a really important one because the climate crisis is very serious, and we're not going to be able to solve it unless we have a lot of good, educated brains to work at the problem together. So we really need kids to be learning what they can in school, not just about science, but also about the law, also about finance and how to get money to do all the things that we need to do to make changes. There's so many different things that we need to do on different fronts. And so we need all hands on deck. We need all brains on deck. And this is probably the most important, is organize and raise your voice. We as individuals, we can't individually always just deal with climate change on our own, right? Like it's fine if, I think it's important that we try to do what we can individually, like to eat less meat or to buy less stuff. But ultimately we have to heat our homes somehow. We have to stay warm somehow. We have to get from A to B, from school or to work somehow. All of those big challenges, they're going to need to be coordinated by big institutions like our government. And our government really needs to hear young people's voices, because you are the ones that are going to be most impacted. So that is really, really important. I know that Clague has a middle school organization for climate change. I don't know if there are in your school or in other schools or not, but if there isn't, you could be the one to start one. And I'm happy to help share some resources. And I'll share my email in the chat in a little bit if anyone wants to get in touch. All right, and this is the last sort of slide here. Climate summit. What if it's a big hoax? So you still have people talking about climate change being a hoax, which it most certainly is not. Science has overwhelmingly shown that climate change is happening, that humans are causing it, and we have about 10 years to make radical change. And we're on our way, but we certainly need to do a lot more. But a lot of the climate solutions that we hope to have, they're not just going to be good for the climate, they're also going to be good for us as a society. They're going to be good for justice, for social justice, for equity, and just to be a better, kinder, more fair society. And I think most kids will agree, and most adults will agree, that that is a good thing that we should be doing anyway. So I'll also, Amy, would it be possible? Oh, thank you, Amy. And I can also put this link up from this climate quiz in the chat. I don't think we'll have time to go through it today, but I'll put a link.
That would be perfect. And Smita, we can also send out, if it's okay with you, the PowerPoint presentation to the attendees today.
Oh yeah, that would be great.
Perfect.
That'd be great. So I'll share that with Ms. Carpenter, and then we can forward that on to you. Does anyone have any questions for me? I know I went through like a lot of different kind of sciencey. I hope this wasn't like too hardcore science, and I hope I didn't lose too many people along the way, but does anyone have questions for me, or you can always feel free to email me too if you don't think of questions right now and you think of something later. Nothing? All right. Well, that's it for me for now. I hope this was helpful for you. I hope this introduced you to some concepts that you hopefully will be able to tell your friends about. And kids are a great source of information for other kids. So, there's a famous quote, "Be the change that you want to see in the world." And I hope all of you do your best to live up to that. Be the change that you want to see in the world. So, yeah. Oh, thank you. I see so many kind words in the chat. Thank you so much. I really appreciate it. And all the best to all of you.